In this video, I would like to talk to you about some ways for expressing the solution set to an inequality, and specifically interval notation. So in the last video that we talked about, we mentioned some of the differences between equations and inequalities. And one of the differences was that the solutions to an inequality are generally not possible to list, whereas an equation might have a finite number of solutions, like 1 or 2 or maybe even none at all. An inequality almost always has infinitely many solutions. So let me show you an example very quickly to just have something to work with. So say you have an inequality like this one, 3x plus 2 is less than or equal to -7. Okay, so this is a linear inequality. The actual mechanics of solving it should not cause too much of a problem. So we are subtracting 2 from both sides. We get 3x is less than or equal to -2. Now we divide both sides by 3. And we finish with x is less than or equal to -3. So again, I'd like to reiterate that what we're saying is that any number less than or equal to -3 satisfies this inequality. One thing that I think it's good to do, and we haven't done it yet, is to actually see what that means. So for example, check 1 value. What I'm saying here is I can pick any value, -3 or smaller, and it should satisfy this inequality. So let's try -3 itself, right? So you have 3x plus 2. So I'm putting -3 in place of x. And I'm asking, is 3 times -3 plus 2 less than or equal to -7? Well, in fact, -9 plus 2 is -7, and since this symbol of inequality means less than or equal to, that tells me that yes, -3 does satisfy the inequality. And now you can pick any number less than or equal to -3. So just to say we did, let's try it with like -7 or something. I'm picking -7 at random. There's no particular significance to the number -7 here. So 3 times -7 is -21. Plus 2 is -21. Plus 2 is -19. So yes, -19 is in fact less than -7. So since we need to be either less than or equal to, that is also true. Now, I don't want to have to write this out like this every time, right? Any number less than or equal to -3 satisfies this inequality. So that's where interval notation comes in. Interval notation is all about the number line. Okay? An interval describes essentially a section or a piece of the real number line. So it's entirely possible that you've worked with interval notation a little bit before, but so this is going to serve as a quick review. So what are the mechanics of an interval? An interval has 2 endpoints. And as soon as I write this, I'm going to put a little red asterisk on top of it because it's not always strictly true what I just said. So I'll come back to that. And then the other thing, an interval communicates or makes clear whether the endpoints themselves are included. How does it do that? Well, a square bracket means that we include the endpoint, and a round bracket or a parenthesis means we do not include. So for example, the interval from -7 to 5 with brackets on either end is the interval of all the real numbers. And I'm actually going to underline the word real here, and I'll say why in a minute. All the real numbers between -7 and 5, inclusive. So the number -7 is part of this interval. The number 5 is part of this interval. So by putting brackets on either end, we are communicating that the endpoints are part of this interval. Here's another example. So say that we have the interval from -4 to 3. So you'll notice that I have a parenthesis on one side and a bracket on the other. So what I'm saying here is this is all the real numbers. And again, I'm going to underline the word real. All the real numbers between -4 and 3, including the 3, but not the -4. Okay? So what I'd like to sort of point out here as maybe a bit of a cautionary moment. So caution. Saying that we're not including the -4 is not the same as saying, oh, well, then just start it at -3 and include the -3. The reason that these are not the same thing is that we're talking about the real numbers here. And -4 and -3 are integers. There are lots of real numbers. In fact, there are infinitely many real numbers between -4 and -3. So for example, -3.5 is included in the interval that we're talking about. But -3.5 is not included in this one that starts at -3 and goes to 3. So be really careful, because intervals are not just describing whole numbers or integers. They're describing all of the reals. Now, you'll remember that up here, I put a little red asterisk to sort of come back to. So let's talk about it. An interval doesn't actually have to have two endpoints. An interval could go on forever. So here's an example of such an interval. Okay. 7, infinity. So this is the infinity symbol, the sideways 8 figure. And when one of the endpoints is the infinity symbol, this actually signifies that the interval never comes to an end. Once it starts going, it never stops. Because that symbol serves to indicate this idea, infinity is not a real number. It's just a symbol describing this idea that we are going on forever. Infinity, when it shows up as an endpoint of an interval, always gets a parenthesis. It is not possible to include infinity, since infinity is not a real number. So I want to write here what this interval means is all the real numbers greater than or equal to 7. The reason that it's greater than or equal to is that we have this bracket around the 7. By that same token, we might have something like this. Okay, so just an example of another interval where one of the endpoints is infinite, where both of the endpoints have parentheses. So if you wanted to describe this one in words, you would say all the real numbers strictly less than -2. Okay, so that is a quick review of interval notation, and we will be using interval notation almost exclusively when we are talking about describing solutions to inequalities. We will also graph our solutions on the number line, and you'll notice in a future lesson that I will do that the graph on the number line and interval notation, they're practically the same thing. They're just, one is a visualization of the other. So it's really important to be thinking of an interval as a section of the number line, because then it's very easy to make the connection between number line graphs and interval notation. I will finish this lesson just by going back to the example that we were talking about at the very beginning, which was this inequality, 3x plus 2 is less than or equal to -7. And you'll remember that we came to this solution set at the end, that any real number less than or equal to -3 is a solution to this inequality. So we can go back here and we can add that the solution set can be described in interval notation as starting at -infinity and going all the way up to and including -3. I'm not going to talk about graphing intervals on the number line in this particular lesson, but if you'd like to try it, and if you think that it would be helpful for you to see what's going on, then please by all means give it a go. And if you have questions, feel free to ask them in our office hours or in discussion posts. See you next time. Bye.